Are you ready to hear more about Flutter and how is a cross-platform done right? Our next speaker is a mobile and backend engineer with over 10 years of experience in Flutter, iOS, and backend development. Her work focuses on scalable architecture, clean code, and best practices, while also leading and mentoring development teams. When she's not optimizing code, she is busy debugging her life with her 2 kids and one very opinionated cat. Who has a cat here? Only the speaker or someone else as well? Okay, so you can share experiences about opinionated cats. Okay, now Mariana, please join me on the stage and tell us more about the Flutter's role in scalable software ecosystems. The floor is yours, lady.
Thank you. Okay, this is scary. Okay, hi everyone, and thank you for being here and listening. In this talk, I'm going to walk you through an entire cycle of a mobile application development, from clean architecture and API design to CI/CD pipelines and QA workflows. We'll cover the basics of how a Flutter fits into a modern, scalable software ecosystem. But first things first, let's go over the introduction. My name is Mariana, and I've been a software engineer for a little over 10 years. I started my journey as an iOS developer, then switched to backend development with Ruby on Rails for a bit, which was an interesting change of context. And then moved back to mobile app development, and now I've been working with Flutter for the last 4 or 5 years. I'm currently working as one of the Flutter team leads at RightTech. On the personal side, I am a proud mom of 2. My daughter is 4 and my son is 1, so they definitely do keep my life interesting. Other than that, feel free to connect with me on any of my social networks. I'm always happy to chat, share insights, or talk or discuss any questions that you might have. First disclaimer, so this is not an official app, but to make this talk more practical, I've created an application that's built in Flutter, obviously, that covers many of the principles that we're going to discuss in the next couple of slides for building a scalable Flutter product. Now, the application itself is really simple. There is a list of speakers. We have the schedule with the full agenda, and we have some resources that some attendees might find useful. Now, this is you can find the code on my GitHub page, which you have the link below. And I would encourage you to follow along with the code as we go through the presentation. This is not meant to be a production app, but rather a living example of how to put certain Flutter practices, certain Flutter patterns, into a real-life practice. So next, let's go over to the agenda and see what we're going to discuss in the next few slides. So we'll kick things off by covering the foundational reasons of why Flutter is a good choice when it comes to a cross-platform application. Next, we are going to talk a bit about clean architecture and the importance of modularizing your application. After covering that part, we'll switch gears to the backend, and we'll try to understand how we can improve the interaction between the mobile front end and the backend. Now, an application is truly scalable without the developer process being scalable itself. So we are also going to discuss automating build and deployment. While on the topic of automating, we'll also mention automating our tests in a CI pipeline and talk a bit about Flutter's unit widget and integration test. At the end of the presentation, we are going to cover some common mistakes that we do when trying to scale Flutter apps, and we'll wrap up with a summary and open up the floor for Q&As. Okay, so first of all, let's see why Flutter is a good choice for scalable apps. So Flutter now supports multiple platforms, and it has one code base for iOS, Android, web, and even desktop. So that drastically reduced development time and cost as well. There's also a fast development cycle thanks to the hot reload. And for those of you that are not familiar with it, hot reload is a feature in Flutter that you can see on the GIF on the right side. It's a feature in Flutter that enables developers to see their changes of the code without having to restart the application or lose its state. Next step is Flutter's performance. So Flutter is really performant because unlike other hybrid cross-platform solutions, Flutter actually does not use web views or bridges to communicate with its native parts, but it actually compiles to native ARM code, which brings it really closer to native performance. And what it also has is a custom UI rendering engine, which gives us UI consistency across all platforms. Another thing is that the Flutter community is continually growing, so we have constantly growing ecosystem and support for multiple tools. All of these points lead to faster time to market. Okay, so let's say we want to build a speaker feature for our demo DevCon application. At the center, we have the Flutter application, and the Flutter app will be the core interface that the users interact with through their respective platforms. But this is not the only thing that we need in order to build a feature. So first of all, we need the designers to add the design to Figma, for example. We need the backend team to expose the data through their APIs. We need QA to actually verify our implementation with integration tests. And we need CI to run them all. Now, when all of these layers are in sync, we truly have capability for scaling our application. And additionally, this is the ideal picture of how a Flutter ecosystem should actually look like. Another thing to note is that the application itself should not be built in isolation, but it should present a collaborative workflow across all of these teams. So aside from being collaborative, what we also need is for the app itself to be scalable. Now let's see how we can do that in the next section. So when we talk about scalability, first thing we talk about is modular architecture. So why do we need that? By modularizing our Flutter application, we unlock a range of benefits that will make our application faster and more scalable. Now, first, separation of concerns. Now, each feature or domain will have its own independent responsibility. We have improved maintainability by having smaller, isolated modules that are easier to build, maintain, test, and update. We have increased team collaboration because when we have different modules that are independent from each other, we can have different teams working on each of these modules without actually having conflicts. We have faster build times because we have smaller modules. We have reusability because we can extract common logic and share it across our applications. And of course, we have better scalability because basically we can just add modules to the application without breaking the existing implementation. Okay, so for example, I have the initial structure of the DevCon app when we start implementing a feature. So we start simple. We have the shared folder with some common resources for the entire application. And we have a feature separated folder that starts with the landing page. Now, the landing part is simple because it's only UI. Now, what happens when we want to add another feature to the application? Let's say the home part. It should be actually called speakers, but still, this is the speakers page. Now, basically, we add it at the same the same way we add the landing page folder. Now, when we want to add even more features to the app, we follow those steps. Now, what I realized that I've missed here is that I don't actually have the fully correct folder structure in the home speakers and resources part, because what is really important in application and each feature module is to follow clean architecture. So what we also need here is to have separated the data layer, the domain layer, and the presentation layer. Now, only then the application will be truly scalable. And that's what scaling basically should be, plug and play. We add a feature, connect the route, and that's basically it. Okay, so when we talk about optimization, another thing is to look at is API optimization. So in mobile, the biggest bottleneck is not memory or CPU, but network. So now why the optimization matters? So first of all, the users might have poor connection on, they are connected to some unreliable network. Users want fast and snappy apps, so there is a lot latency sensitivity there. We also need to pay attention to the battery usage. Like if we have a lot of inefficient API calls, that will drain the battery and affect the overall user experience. Now, every part of this has a significant impact on the user experience. So slow API equals slow application equals frustrated users. Now, there are a bunch of steps we can take in order to improve the interaction between the backend and the frontend. So when we usually talk about improving that networking in a mobile application, we start off with caching. So what we basically want to do here is to avoid making unnecessary API calls if we've already fetched the data previously. When we mention in-memory caching, we can also cache essential data in the application storage and sync with when the connection returns. That way we'll display data even when you're offline. We also do not want to spam the API with unnecessary requests. Like for example, if you're building a search bar, you do not want to send an API request on every keystroke, but rather wait for the user to finish typing and then send the API request. When you have large data sets or infinite feeds, you want to fetch only what you need. You do not need the entire data set. What we also want to do is to decrease the payload. So we also want to fetch only the fields that we actually need, not the entire structure. From the UX perspective, we might want to make the app more resilient to bad networks and maybe add some retry policies there. If we have a significantly large payload, as I mentioned previously, we can maybe try using compression. And last, I left this for as the last point because I haven't actually met this in a real-life scenario. But in the ideal world, we will choose the backend API based on the application needs, especially if the application is heavy on performance. So if you need something lightweight, you'll probably use REST. But if we need maybe some more dynamic UI or something that's actually more dynamically structured data, we'll probably use GraphQL. But to be honest, I haven't gotten a chance to actually do that. It will be really nice for the mobile application to be part of the architectural decisions that happen on the backend. Usually the mobile application is just a consumer. Okay, so when we talk about scaling, we do not only need to scale the app, but scale the entire process, development process itself. Now, this is where CI/CD comes to the point. So why do we want? We want faster feedback loops. We want to know early if something is not working. We want to have consistent builds on standardized environments, so we can avoid stuff like it works on my machine. We want to automate repetitive tasks such as code signing and versioning and maybe even deployment. Now, the key areas that we will like to focus on are automating the builds, distributing the builds to the testers and maybe production, automating the tests so we know everything runs well on each change, and we want to automate the deployment. Now, there are a bunch of tools that can be used for this part, And I would advise you to, if you would like deep dive into CI/CD, to go to your nearest DevOps, as I always would do. And also, although I don't have any practical experience with CodeMagic and Bitrise, I do have some with Fastlane and GitHub Actions. And when it comes to Flutter, so Fastlane is really easy to automate the code signing and the deployment. It basically becomes a one-liner. And when you, I find that GitHub Actions really make easy for me to tailor my pipeline to my application needs. So let's see the pipeline for our DevCon application. Now, this pipeline is split into two parts. So one part runs when we make the pull request. The other part runs when the code is pushed to the default branch. Now, for the first part, I've included the analyzer to know really if there's anything regarding the code that should be fixed before merging with the default branch. And I want to run my entire test suite to make sure that no broken code gets merged in. Now, when each of these steps pass, and when I also pass the peer review, the code gets pushed to the default branch, and we have the second part of the pipeline running and building the corresponding Android and iOS applications. Now, the next logical step for this would be to automate the deployment as well. That is, if my Android build ever succeeds. Okay, so when we talk about automation, we also want to talk about automating our tests, which I mentioned in one part of the pipeline. So I think I said it at the beginning. So no application is truly scalable without testing. So when we want to work at scale, manual testing simply doesn't cut it. Now, Flutter offers us 3 levels of testing. We have unit test, widget test, and integration test. Now, at your right, I've also added a small pyramid that will explain to us how it's really important to test the right things at the right level. Now, at the bottom of the pyramid, I hope you all can see the text. So we have the unit test. Now, these are focused on individual functions or classes. They are fast and cheap, so we write lots of them. Next up, we have our widget tests. Now, they are focused on testing the UI in isolation. Now, since they involve some UI rendering, they are a bit slower, so we will write fewer of them. Now, at the top of the pyramid are in the integration tests. Now, these actually test a real user flow from separate classes and from a few classes and a couple of services. So they're really expensive to do and are a lot slower, so we write even fewer of them. But so as we go up, the speed decreases, but additionally, we gain confidence. Now, I sometimes get the question, how much test coverage is enough? I've also tried, while I was working on backend, I also tried to achieve 100% coverage, which I think is not really doable. But I think the appropriate answer here is that enough test coverage is the one that will make me more confident and that I'd be able to actually sleep at night without having to worry about the next features. If you don't have a current test setup, you want to start small. You do not want to start testing everything at once. Start from the most critical path and then grow your test suite from there. Now, in development teams, what also really matters is the naming and the structure. So if you have poorly named, slow tests that are a bit flaky, developers will avoid them. So we want tests not to be a chore, but rather a solid, good practice. Now, testing enables refactoring. So that means we can, every time we want to change the code, we will be confident that we can actually do that. Okay, so now that we covered the basic layers of scaling an entire development system, we'll continue with viewing a few of the common mistakes that are usually made when trying to scale a Flutter application. So first of all, we'll cover state management. So many teams tend to choose a state management approach that is probably trending, or maybe having none at all, which leaves you with calling set state everywhere. Instead, we want to adopt a strategy early, whether it's block, qubit, riverport, or anything else. You want to adopt it and apply it consistently through the code base. Next up, we've covered this one with the API optimization. So we want to avoid having inefficient API calls and focus on things like caching, pagination, and debouncing. Mixing UI and business logic is a classic. So in order not to have this, we want to follow clean architecture. We want to put the UI where it belongs, only in the presentation layer. We want to have separate layers and separate concerns. We also do not want to put our code under one lib folder because that simply doesn't work, neither at scale or in small apps. So we want to have a modularization of our application by feature and then having them isolated. This is one of the mistakes I most often make, is that I ignore that Flutter is cross-platform. So I come from an iOS background, so I usually test my application on iOS, and I just assume that everything works, but it doesn't always. So we want to test across platform and handle if there are any differences. Also, having a dependency injection tool will really improve your the managing of dependencies. We don't want to actually not have that and actually pay the price later, especially in tests. Now, let's go through some common patterns that we might want to use to make our process even easier. So we want to keep things isolated and easier to maintain. We want to use code generation. Tools like Freeze and JSON serializable can reduce our boilerplate and are less error-prone. What we also could use is having a centralized theming system, so the UI is consistent and updating is really easier. We also want to extract our reusable logic and maybe even use it in other applications. We want to follow the rule for the testing pyramid and focus on unit and widget tests first, and then our E2E tests will be light but really effective and test only the crucial parts of the app. We might also want to enforce quality and having linking and formatting checks as part of our automation process. Okay, so up next we have, so this is the summary of everything that we've covered. And I just want to say a few things here. So we want to think architecture first. So scaling basically starts with structure. We want to optimize what you build and not just how you build it. When it comes to testing, automation is key, and automation should be our allies. So CI, CD, and testing should handle the heavy workload. And we also want to learn from our mistakes and adopt strategies early. Now, we've covered a lot of parts in this presentation, and I just want to show you a simple visual summary of everything that we've talked about. So at the foundation, we have our modular architecture. So we want to structure our app properly. Next up, we have CI/CD and automation. We want to automate build, test, deployment, and keep our pipeline clean and consistent. We want to have established a testing strategy. We use unit tests for speed, widget tests for confidence, and integration tests for real-world stability. And finally, we want to improve our performance with API optimization and following some scalable patterns. We want to build reusable logic and abstract any API details behind a clean interface. If there's one thing I hope you'll take away from this, is that scalability isn't basically just about code. So thank you very much for listening, and let's see if you have any questions.
It was a truly great presentation. Any questions? Please raise your hand. Okay, we do have a lot of questions. I cannot see if there is someone from the app. Okay, let's first go with the person upstairs.
Hey. Oh, thank you. So what kind of state management solutions do you recommend for large code bases? I know that Riverpod is popular, and you've mentioned a few others, but I was just wondering what your thoughts were on that for like effectively creating a blueprint to scale something out that could hit like 100, 200,000 lines of code.
Yeah. Okay. Fair question. I've come to, so for my experience, I would probably use Qubit because it really has less boilerplate and it's really easy to scale. And it's also, what is also really good about that is that it has a small learning curve. I've also tried Getix, that's fairly new, but it tends to get a little bit complicated, especially if there are more unexperienced people in the team. But when it comes to state management, I think another important aspect to consider is what the team knows. So you don't want to have a large learning curve when you adopt any approach. And you want that approach to fit your problem, actually.
Thank you. We have a question over there on the green row. Okay. Is everything okay? Yep, cool. Can you say it just out loud?
Yeah.
Or let's try with the other microphone. Okay.
Or, yeah,
Okay.
great presentation.
Thank you.
I really like it. So Flutter is on my bucket list to learn. I have two questions. The first one is, do you have like experience with other cross-platform technologies, frameworks, like React Native and Kotlin multi-platform like that?
Yeah, I actually do. So when I was working iOS and I knew that it was time to switch to cross-platform actually. So I wanted to decide between those two. So I tried React Native and I tried Flutter, and it was really more easier for me to adopt Dart. And I actually saw a lot of potential a couple of years ago in Flutter. And yeah, it does have incredibly good performances. What I also got a chance to do is to do some POC SDKs with Cordova, React Native, and Flutter, and really Flutter beats them all.
Yeah. So if you have experience, so the second question is, why should I choose Flutter over React Native or Kotlin multi-platforms, like in the field of developer experience, performance? Because we know that Flutter is more, it's not really native like the native Android building Kotlin and Java and for iOS like Swift, but it's more performance from React Native, but I don't know if it is more performance than Kotlin multi-platform. I asked the same question to another guy. I think his name was Daniel. He had like a same presentation, but for Kotlin multi-platform. So we asked him, why should we should choose Kotlin multi-platform over Flutter, and he gave us great answers. So I'm asking the same, but like why should we?
Actually, yeah, I have a former colleague of mine that really advocates for Kotlin multi-platform and actually tries to switch me to use that, but I didn't get a chance to actually get a hands-on experience with Kotlin, and I would love to do so before I answer that question. Before I actually make a comparison. As for React Native, yes, I know it's really it is more performant. The only thing I have issue with Flutter is that it's not as performant on web, so it cannot compare to the web frameworks that we currently have. But as I mentioned, the Flutter ecosystem is pretty much growing, and there is more and more support as we go. So I do see a lot of potential here, and it's better than writing JavaScript. Yeah. So.
I think that, we do have time for one more question. We can, or maybe two. Okay, cool.
Hello.
Hi.
I will touch on the question that the man in the front row asked. Is there an easy way to migrate from Kotlin or Swift to Flutter?
No. Actually, the application that I'm working at right now has its native counterparts. It's really a large scale app. It's part of actually my presentation, why I did this presentation. But doing so is not really easy. So you have different contexts, you have different patterns, the really different parts. And when you migrate an application, you know, someone comes, hey, we can do this as well. Like, let's add a feature to this migration. and that's when things blow up, basically. But I haven't seen an actual easy migration so far.
Thank you.
Thank you. And I think that we had a question over there, yeah, on the last row, in the last row.
Hello. I wanted to ask you if you are familiar with ServerPod. That's a backend framework that uses Dart language. And so my question is, are you familiar with it, and what's your opinion? Because on paper it looked really good, but I never had a chance to work on it. It generates all of the data structures, classes, all that code to communicate between backend and frontend. All the IP points are auto-generated. So my question is, are you familiar, and what's your opinion?
I've read a paper on that one. A blog post or something. So it looks really good. It looks really that it has potential, but I haven't actually gotten a chance to work on it. Look, as I mentioned, in most cases, the mobile applications are just consumers of a predefined backend API. So I'm trying to have a more of a say in that, but it's not how it works. Yeah, but I would love to see that in action, actually.
Thank you.
Thank you.
I think that we are running out of time, so we can have you can have your last question during the coffee break, which is right after now. Thank you, Mariana, once again.
Thank you for listening. Thank you.